Okay, my goal is to walk you through problem number one and make it as clear as possible. Okay, there are two kids that might end up as captain and co-captain. If we just draw their names out at random, we want to know what's the chance that, Chantel could end up here and Clover could end up there, or Clover could end up here and Chantel end up over there, right? Well, that number, the two different ways that could happen would be two. You agree with me on that? There's two, right? Okay. Now, the rest of it, right? Like we've got a bunch of other kids sitting there that are going to be picked, and we want to know, how many different ways could we pick those 10 kids that are still remaining? Now, there's no way that it's going to get repeated because they're 10 individual kids, right? Does that make sense? There's 10 individual kids that we're moving around and putting in order. So as I follow the little flow chart here, what I want to do is I want to see if this can make sense here. The order does matter because if we pick Chantel first, she's going to be captain. Clover second, she's going to be co-captain, right? And so what I'm going to do is I'm going to move this down here through my flow chart. Order matters, and I'm going to go to no repetition because every kid is going to have a spot on the team. Now, I know it might not sound important, but there's going to be a number 3 kid pick. There's going to be a number 4 kid pick, number 5, 6, 7, 8, 9, 10, 11, 12. Now, I know the other kids don't have leadership positions, but the first two do. So what I'm going to say is I'm going to say there's 2 ways to pick Chantel and Clover. Okay, so I'm going to go 2 times. And then what I'm going to do is 10 permutate 10. And in the denominator, we have 12 kids. And I'm going to go 12 permutate 12. So let me zoom back out for just 1 second here. Why did I end up over here in permutations? Because I'm claiming in problem number 1 that the order does matter. And after we pick our first 2 spots, 1 and 2, Clover, Chantel, or Chantel, Clover, then we got 10 other spots to fill on the team, right? And we want to know the total number of ways that you could line up 12 kids, in different orders. And so now I need to follow this little formula over here. Well, let me zoom back in here and let's see if we can keep the formula on the screen. The formula looks like this. I go 2 times, and I go 10 factorial all over 10 minus 10. That's what that means right there. 10 minus 10 would be 0 factorial. And then I've got, now you might say you can't divide by 0. We'll talk about that in just a second. 12 factorial all over 0 factorial, right? 12 minus 12. Okay, so what happens here? This is 1. That number is 1 right there. And what is 10 factorial? We talked about that in class. So I'm going to go 2 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's all over 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what factorial means. Now look, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All of those guys are divisible 1 time by each one of these factors. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So sometimes we use the word cancel. I'm just crossing them out to say they divided out to 1. All of that's 1. All of this 1 down here, right? What do we got? We got 2 over 12 times 11. 2 over 12 times 11. Well, 2 goes into 12 6 times, so I'm going to put a little slash through this and say that's a 1, and then this is a 6. I'm dividing a common factor of 2 out of each one of those guys. So I get 1 over 6 times 11, which is 1 over 66. All right, that's how you do problem number 1. I want you to, try problem number, I think it's 5 next. You're going to see it in my next video. And we're going to kind of work through the homework, different examples together, and then you'll try to finish the rest of the homework. Thanks for watching.